Got it. Okay, so we get this on the website.
Thank you.
So now that the stream has started, I will say once again, welcome to the March meeting of Palomar Amateur Radio Club. And now I will turn it over to your Vice President, Michelle, W5NYV, to introduce the speakers for tonight.
Well, thank you so much. Tonight, we're going to hear two speakers who are going to share their experiences with Voice of America, the largest and oldest U.S.-funded international broadcaster. VOA produces digital TV and radio content in over 40 languages, and it's heard around the world. Our first story is shared by Kim Elliott, KD9XB. It's about how the interactive digital programming from Voice of America became the highly popular Shortwave Radiogram. Kim will explain how you can participate in this fun and educational weekly on-the-air event. After that, another story will be about restoring a transmitter from one of the Voice of America radio sites, told by Dennis Kidder, W6DQ. Both are first-time speakers at PARC. We welcome both of them, and it is the floor is yours, Kim.
All right, I'm just unmuted. You're hearing me okay?
Yes.
Okay, the audio is working here. So the next thing I have to do, and I haven't done this for a while, is the good old share screen deal. So hang in there while I do this. And
should work. Let me know if it doesn't.
Are you seeing a slideshow?
Not yet. We see you.
Okay. Oh, I see. I gotta share.
Yeah, that's we see a screen.
We're getting close.
You are.
Yeah.
We're getting close.
There you go.
How about that? Is that working?
Yeah, that's working. Thank you. And
all right,
Joseph,
there's always that one step.
That's right. Joseph, you may want to spotlight Kim. That might be something you might want to do.
Yeah, I had done that, and then when he started sharing, the spotlight got removed. So there we go. Spotlight it again.
Yeah, it was entirely my fault. I clicked it off by accident.
Oh, okay.
All right, so we are ready to roll.
Yes.
I don't want to hold you too long.
Yes, we're ready to roll.
Okay, so let me talk about Shortwave Radiogram. I'm Kim, KD9XB, and I worked at Voice of America till 2017 when I retired after 32 years there. I did audience research for them, and then I also had a program at VOA called Communications World, which is developments in media around the world. And then towards the end of my tenure, they let me do a program called VOA Radiogram. So around the years 2011, 2012, I was noticing that more and more countries were starting to block the internet, including VOA content. Certainly China had done this by then. Iran was threatening to do it and was doing it occasionally. Russia was certainly planning to do it. And even some smaller countries would, during times of crises, cut off their internet. So I was thinking, well, all right, maybe we can use shortwave to get around the blockage of the internet at borders, and then get it into the country to the people who still can, who still have radios, and then from their radios they can take the content and pass it on to what has become the country's intranet, or through text messages. I wasn't expecting that millions of people in the target country would be using digital digital amateur radio technology, but a few thousands of people would be doing that. It was also at about that time, 2011, 2012, that I first learned about the digital modes of amateur radio, and it was up in the VOA Amateur Radio Club shack that I first saw PSK31. It was the big digital mode back then. And I was just amazed at how it was decoding, even though the signal was tiny. And it was just took a narrow sliver of spectrum space. So I thought, gee, well, maybe there's something to this that we could use in the broadcasting business. So this became VOA Radiogram, 4.5 hours a week, all from the Greenville transmitting station, which is the last VOA USAGM shortwave transmitting station in the US. We were on for the half hour, and we tried all the modes that the amateurs had at their disposal, like the PSK31 and the QPSK and the MD, I forget what those are called, and the Thor and the Dominoes and everything else. But we've eventually found out that the MFSK32 and MFSK64 turned out to be the most successful, and they had the added advantage of being able to do images as well as text. And then when I retired in 2017, I offered to stay as a contractor for $5 a year or something like that, but I think they really wanted me out the door. So I turned it the very week after I retired. I was on the air on private US shortwave stations and changed the name to the program to Shortwave Radiogram. And 7.5 hours via WRMI in Florida and WINB in Pennsylvania. It's transmitted in the AM mode, just like a regular broadcast. But you can receive it in AM or USB or LSB. Your choice. Now, if you want to receive this, you can use your amateur radio transceiver. That's because almost all the transceivers have general coverage receivers now. Or you can use a shortwave receiver, including inexpensive portables with no sideband. If it's just a cheap portable with only AM mode reception, you can use that. You can also use one of the remote SDRs that you can access through the internet. I do that all the time to see how my signal's getting out. For decoding, there's some software available. I wish there were more, but the big one, of course, is FLDigi from w1hkj.com. That's what most people use. And then there's Multi-PSK from France, which is works well. The interface is a little weird. And then if you have an Android device, TVAR and FL Message, you can go to W1HKJ to get it, either one of those. TVAR, text and images via analog radio. That's just for receiving and decoding. The and FL Message you can use for encoding and transmitting. So it's an amateur radio app. Decoding can be as simple as placing a portable radio next to an Android device and doing, of course, what's known as acoustic coupling. And so the sound from the speaker is going into the microphone of the Android device. Just got to keep the area fairly quiet. Doesn't have to be dead quiet, but fairly quiet. So that's how a lot of people do it. This is how the show works. I start with the theme music, and then I do an introduction with voice for about a minute. And then we do a news item in MFSK 32, 120 words per minute. News item in MFSK 64, 240 words per minute. So if reception is not so great, the MFSK usually gets through, and then if it's a really lousy signal that week or for that area, reception area, the MFSK 64 might not work. But if reception is good, then that lets us go up to a much faster transmission speed. And then we end the show with several images, usually anywhere from 8 to 12 images in MFSK 64. The listeners really like that because they're colorful and kind of fun to play with. And occasionally we experiment with other modes like Olivia 64-2000. We have in the sideband of a broadcast transmitter 2000 hertz to play with. So sometimes we'll use those really wide modes, and some of them work very well under poor conditions. Under conditions where you can barely hear the signal, you're getting 100% decode. Might be kind of slow, but it works. This is an example of results sent in by a listener. This is our listener in Denver. So showing the pictures that were received that particular week. Down in the bottom right corner is we start with like a waterfall art. So that's in the waterfall of an SDR. So showing the name of the program, and also that particular week we were experimenting with Burmese. We can transmit text in exotic alphabets, even right to left alphabets like Arabic and Persian. And this weekend on the show, I'm going to be transmitting Russian. Did Ukrainian 2 or 3 weeks ago, just to try to get the international broadcasters interested in this. So far unsuccessfully, but I keep plugging away. We also enjoy the differing quality of images under differing types of reception. So upper left-hand corner, you can see the original picture, and then you'll see reception deteriorating until you get to the one in the bottom right. But we love it when when a photograph is turned into an impressionist painting. And so some of them look really cool and very artistic, even though they're fuzzy. So we don't consider fuzzy images bad. We consider them artistic. Here's a schedule, and don't try to write it all down because it's in the website that I'll show you here in a minute. But one thing you might note is that tomorrow evening at 0:30 UTC, that's Friday UTC, but no, that's Thursday night our time. And so that'll be, let's see, 4:30 p.m. Your time in California. 9265, that transmission from WINB usually makes it to California. So if you want to try it out soon, 4:30 p.m. Pacific time, Standard Time, tomorrow on 9265 kilohertz from WINB, Pennsylvania, you probably will be able to hear it. The other good time for California is 0800 on Saturday. That's what, midnight your time? Yeah, midnight on Sunday morning. Not a very convenient hour. So if you want information, there's the website. So the website's got the schedule, and it's usually just a couple of hours before the first program on Thursday our time, Friday UTC. I do the preview of what's going to be transmitted that weekend. You can email me at radiogram@verizon.net. Twitter now is a good way to find out what's going on, because the listeners post their results on Twitter, and I retweet them, and then you can see there what sorts of results with images and text people have been getting for the weekend. And if you don't have Twitter, just go to the URL, twitter.com/SW Radiogram. And then there are YouTube videos often of the show where you can see the people decoding what they've decoded. Just go to YouTube and search for Shortwave Radiogram in quotation marks. And that's it for my presentation. Thanks for inviting me, and thanks for your interest. And let me see if I can get out of this thing.
Yeah, thank you so much. We're going to open the floor for questions. My first contribution is the way that I receive shortwave radiogram is with a remoted SDR, and I got a lot of timing slip damage from from doing this. So not exactly the same as noise or interference, but the whole image would be shifted over. And in the process of looking at this, and I learned, in otherwise perfect copy. So it was an opportunity to learn all about the weird timing stuff that happens in a flex radio, and with the smart link, there's some peculiarities. So there's tons and tons of things to learn all throughout Shortwave Radiogram. All right, so we're going to open.
If you have figured out what the how to fix those sync errors, let me know. Let our listeners know.
Okay, yeah, I'll do a little write-up of what I've learned so far. Okay, the floor is open for questions.
I have a question.
Please.
You mentioned at the beginning that you start out with music. How do you get around the fact that we're not supposed to do music on amateur radio?
We're a broadcast, shortwave broadcast station.
So. Oh, shortwave. Got it. Okay.
Yeah.
So not on amateur radio. Okay. I missed that part. Thank you.
So what we're doing is we're applying some of the techniques of amateur radio to a shortwave broadcast transmitter.
Got it. Okay. I missed the frequency. So I was getting.
You can do this on an AM and FM too. If you know somebody has an AM radio station, you could have some fun with digital modes, like maybe at 3 in the morning when they don't care.
Great. Thanks.
Yep.
Hey, Kim, this is Bob LaRosette. A quick question for you. Maybe you want to comment on the state of affairs of getting messages, the American message, so to speak, into Eastern Europe and Russia these days. Can you comment on that?
Well, yeah, with this Ukraine situation bubbling up in the last few weeks, I've been getting in contact with people that I know or don't know at VOA and Radio Free Europe and BBC and Deutsche Welle, telling them that we have this capability. We can transmit text and images, the stuff that you put on a website, but we do it outside of the internet. And we can. Not a lot of people are able to do it, but we should be getting the people in those target areas familiar with the concept. And also, if we can transmit this, then receiver manufacturers and software developers will take note and maybe start developing devices and apps that are easier for the audience to use. But we've been noticing, you've been reading the news in the last couple of days about more and more internet being cut off in Russia and Ukraine and other parts of the world, but right now, especially Russia and Ukraine. So I've been doing cartwheels and handstands and everything to try to get attention of the international broadcasters, but so far with no luck. But this weekend on Shortwave Radiogram, we will be transmitting some Cyrillic text in Russian. Maybe that will get some interest.
So does this go out, this AI6RR, does this go out over all Voice of America transmitters? And aren't there some of those in Europe?
Yeah, well, so I was on VOA for a while, and yes, the fact is that our parent, VOA's parent organization, which is now called the U.S. Agency for Global Media, they have transmitter sites in Germany, Biblis and Lampertheim. Those are old Radio Free Europe and Radio Liberty sites. So those would be great for reaching Russia and Ukraine. And a lot of us are wondering, why aren't they doing it? And also there's a big shortwave relay site in Kuwait, and that would work fine too for reaching Russia and Ukraine. You just beam straight north. And then finally, the Greenville, North Carolina transmitter, those wonderful big, huge curtain antennas, those can get across to Russia and Ukraine most days at certain hours of the day.
Well, it was really fascinating. Thanks for coming and sharing. I remember I used to sit at night with my little shortwave radio listening to the Voice of America.
Me
as
too.
a kid.
Me too. Any other?
Second here. Well, I got a question if you want to, if you can, do you hear me okay?
Yes.
Yeah, okay. This is Bob, AK6R. You know, a lot of the AM stations run sidebands, so they can run AM1, AM2, AM3, for example, and they run multiple programs on the sidebands. And can you do, I guess you could do that with your modulation technique too, couldn't you?
So I think you're talking about, are you talking about digital, AM digital? And
Yeah.
yeah, well, we're not completely digital. Like the, what is it? It's called HF.
HD radio.
HD radio. Thank you.
Yeah.
Yeah, which is fun, but and we have some HD radio AM stations around here in our area. The system that I put together, the advantage of it is that you can transmit. You can use any old shortwave transmitter. The one I use for BOA radiogram was built in '62, I think. And you can use any old radio, so you don't need any special equipment, except you do need the software to decode it. But the advantage of the system is that a lot of times with digital radio signals, they drop out if the signal gets down to a certain level, or if you have fading, or if you have interference. That's especially the case with a system called DRM radio on shortwave. But you know how an analog system works. An analog system will fade, but it won't disappear completely. You might get some noise, but it won't disappear completely. Well, what we do is we take that analog signal that doesn't completely go away, and we put a digital mode on the analog carrier. The digital modes have all kinds of error correction and redundancy. So that signal hangs in there. That signal hangs in there even under miserable, horrible, awful reception conditions. But generally, we can only do one program stream at a time. We can't really combine audio and text. We just got to do one at a time.
All right, thank you. Any last questions or comments?
Yeah, a comment.
Please go ahead.
Gail, K6GO, I just want to say how important Voice of America was back in the early 90s down here in Mexico, when there were no satellite dishes yet. There was no way to find out news or about anything going on. And just having a good old fashioned shortwave radio put me in touch. And interestingly, most of the time I had the best signal from Voice of America Africa to the tip of Southern Baja.
Yeah. You know, BOA never had as part of its mission serving Americans abroad, but Americans listened anyway. And it should have been more part of BOA's mission.
I'd like to comment on that.
Go ahead.
I used to listen to the Voice of America.
It's true.
Hello?
Go ahead.
I hear you.
Okay, I didn't know that. I heard the VOA when I lived in Venezuela in the late 50s, early 60s. When the communists started moving in with Castro, VOA was the only source of news we had. A great service.
Mm-hmm. Thank you. Little harder to hear now around the world on shortwave. You got to use the internet to hear us.
All right, thank you so much. This has been fantastic.
Thank you very much for having me. Appreciate your interest.
Our next speaker is Dennis W6DQ, who's going to speak about hardware.
Very good. Thank you, Michelle. Dennis here. Hopefully you're hearing me okay.
Yes.
I'm having some network problems here. We had a power failure today, and my network has not really come back up to full speed since that power failure. So we're going to do the best we can here. Hopefully we'll do okay. I'm going to share my screen, and let's see. You should now see my chart.
Yes.
Okay, super. Well, what we're going to talk about is one of the VOA sites, but I'm going to give you a little background of VOA. Because time is limited, I've pulled some slides out. I've taken a bunch of slides out, but we're going to go over real quickly some things about what the Voice of America is. And you guys kind of touched on that a little bit in Kim's presentation, but there's more background to that as to how it started and what its mission has been all along. So without further ado, you're looking at a photograph there of the Delano relay site here in California. And some of you've probably seen that. You go up Highway 99 up north of Bakersfield, heading out through Delano, and it's off on the horizon, except it's no longer off on the horizon. Those towers have been dropped. I just got word of that recently, that the towers have been destroyed, which is really sad, but it's history. Okay, so what is the Voice of America? It is an official U.S. federal government external broadcast entity, and that's the important thing. It's external. It's not meant for domestic consumption. So it's meant for outside of the United States. And as Kim said, it's under the United States Agency for Global Media, USAGM, and it's one of 5 civilian U.S. international broadcasters. And of course, the first being the Voice of America. You guys mentioned Radio Free Europe and Radio Liberty, Marti, which is going into the Cuba, Caribbean, that area. Radio Marti, you've got Radio Free Asia and the Middle East Broadcast Network. These are the 5 civilian U.S. international broadcasters that fall under the USAGM. So let's see. They do provide programming, as was mentioned before, in radio, TV, and internet. 1,800 hours weekly in 47 different languages. 1,800 hours weekly, and a global weekly audience of more than 278 million people. And they maintain 19 major broadcasting sites or transmitting sites worldwide. One of the sites that was mentioned is Greenville. This is the photograph of one of the antennas, or one of the antenna arrays at the Edward R. Murrow transmitting facility at Greensboro, North Carolina. That is the only one that's left on the continental United States. But there are several other sites still around the world. Sao Tome is the one off the coast of Africa. It's an island off the west coast of Africa. We've got some former sites. Oh, this is the wrong chart. Oops. Oh yeah, that's okay. Yeah, Bethany, former sites. Bethany, Ohio, which was a relay, and I'll explain relay a little later. Bethany, Ohio. Delano, which is the one we're going to be talking about tonight, and Dixon Relay, also in California, up in Northern California. And other sites that were maintained before were Hawaii, Okinawa, Liberia, Costa Rica, and Belize. So yeah, this is the wrong chart. I have updated this of those 19 charts. You mentioned, Kim mentioned Germany. There's a sites in Germany, the Philippines, and there's several other sites around the globe. So those are still in operation. So the history of VOA. Prior to 1939, US shortwave stations were all privately owned. And NBC maintained something called the International, or the White Network, which broadcast in 6 languages. the NBC we're familiar with today, National Broadcasting Corporation. CBS had 64 stations in 18 different countries. And Crosley, we all know Crosley, had 12 experimental transmitters on shortwave. But there was no policy for content, meaning you could broadcast whatever you wanted, and it didn't necessarily represent the view of our government. And so this was a problem. Well, what happened in 1939? We had the start of World War II. The actions in Europe and Asia had a great effect on what content was to be broadcast from the United States. This led to the creation of something called Voices from America. This was first broadcast to Germany using BBC transmitters in England. And the first broadcast was on February 1st, 1942, Stimmen aus Amerika, which is Voices from America. And their charter was, as it says here, today and every day from now on, we will be with you from America to talk about the war. The news may be good or bad for us, but we will always tell you the truth. And this operation was taken over by what was then the Office of War Information. So during World War II, as I mentioned, VOA was sharing transmitters in Europe, BBC, for instance, and they decided they needed to start building their own sites, but they were also using, here in the United States, using some of the domestic broadcasters, the other shortwave broadcasting stations we were talking about. But as the Allies progressed through Europe and Africa, they established some new stations, the American Broadcasting Station. And this is where VOA had their own sites rather than having to use the BBC sites in Europe. In the Pacific Theater, as the war progressed, there was one transmitter in California in 1941, and it was in San Francisco, and I believe it was owned by NBC that was being used. They expanded out to Hawaii and the Philippines to get into Asia. And especially the Philippines, as we captured the Philippines, we were able to build a site there, and that site is still in use today. The war's end, they had 39 transmitters worldwide, transmitting in 40 different languages. So it's quite an accomplishment in a short period of time. But at the end of the war, roughly half of the services were terminated. They shut everything down. And in late 1945, the Voice of America was transferred over from the War Information group to the Department of State, DOS. So what happened next? We entered the Cold War. We got into the Cold War, and in 1947, Voice of America targets the USSR, the Union of I can't even think. Well, anyway, the Soviet Union is targeted by Voice of America. And it was used to counter Soviet propaganda coming out of the Soviet Union and Eastern Europe. So unfortunately, at the same time, we started transmitting into that part of the world. That part of the world started jamming. On April 24th, 1949, the jamming began. So this created a new problem. Well, to counter this problem, Voice of America started up something called Operation Vagabond. Vagabond was a Coast Guard cutter named Courier that was repurposed as a shipborne broadcast and relay station. And it was commissioned on February 15th of 1952, and that's a photograph of it. They operated the ship for 12 years, and you know, to counter the jamming, you just move the ship to wherever you need to move it to and start transmitting, and don't worry about the jamming so much. But some of the cool things about this thing, this was the largest medium wave transmitter ever installed on a ship. They had a 150 kilowatt RCA BT 105 transmitter that you see in that photograph. They also had two Collins 270 B1s, which were 35 kilowatt transmitters. And they had a gaggle of Collins 51J receivers, which you see in this next photograph here, all the racks of 51Js. So this is how they got around the jamming at that time, by building the ship. 12 years it operated. And interesting that the program material was transmitted from a station in the United States out to the ship and recorded on a transcription record, which is then played back on a transcription turntable. So no tape, right? They were just using these vinyl discs. And it'll have some more on that a little bit later on. But you can see this is probably this actually looks like a lathe, actually, rather than a transcription turntable, because I'm looking at the microscope and all that. That's actually where they're cutting the disc to be able to play it back. So they're receiving the material on these receivers and cutting it to a vinyl disc. Kind of interesting. So what came out of this was the creation of USIA, the U.S. Information Agency, United States Information Agency. And this is what I remember as a kid, USIA and Voice of America. This was established in the 50s in 1953 by Eisenhower. And it operated until 1999 under USIA. And their mission is to understand, inform, and influence foreign public in promotion of the national interest and to broaden the dialogue between Americans and U.S. institutions and their counterparts abroad. Again, fulfilling that mission of non-domestic consumption, right? This is all external to the United States. So their role changed. And this was the whole thing about the Smith-Mundt Act was no domestic dissemination of foreign target propaganda. Well, obviously, we could hear it. We could, somebody mentioned here before listening to VOA as a youngster. I mean, I used to listen to Voice of America, probably listening to Delano because I grew up here in the LA area. And it was quite loud down here, even though it was pointed in the other direction. We still got quite a bit of signal from Delano. So I was definitely listening to Voice of America, but it's not for domestic dissemination. But Congress wanted to filter this, and they wanted to be able to control what was being broadcast and have a filter as to what our citizens in the United States were actually listening to. And of course, this got the media and academia all up in arms. So it led to this point of the VOA was forbidden to broadcast to a US audience. Now, this went on until 2012 when that Smith-Mundt Act was revised or amended, and it now allows dissemination in the United States. So it was an interesting time, but obviously the role of Voice of America was to deal with the Eastern Bloc and the Soviet Union and to counter their propaganda. One of the interesting things about Voice of America, it is the world's largest full-service public relations organization. USIA creates broadcast materials, and they have a $2 billion annual budget. And they countered the USSR in 150 countries with their broadcasts. Pretty amazing. So now, let's go on here. I mentioned the Voice of America was a division of USIA that changed recently. Primarily radio broadcasts on shortwave and medium wave. And again, I said the main target is listeners behind the Iron Curtain, Radio Free Europe, right? Their charter was established in 1960, and by 1967, they were transmitting in 38 languages with 26 million listeners worldwide. Now, to present, what's happened today is you're finding, and you mentioned this earlier, that the shortwave broadcasts are becoming fewer and far between. Mainly it's the advancement of technology, internet services, satellite services, this type of thing. It might interest you to know that the Voice of America was the first news broadcast organization on the internet in 1994. And they went on the internet with English language and 44 other languages, which is pretty incredible. And today they've got 20,000 servers located in 71 countries. Wow. So it's a lot of hardware. But that impact of technology, it's the proliferation of the internet and satellite. They kind of did away with shortwave broadcast for the most part. We still have a lot of shortwave broadcasts, but it's not like it used to be. Boy, I did a lot of shortwave listening as a kid, and today it's tough. Mainly, you listen to China and Korea and a few other places. But and the jamming from North Korea, I love that. But yeah, but they maintain these broadcasting services. I mentioned there earlier, there's still 19 transmitting sites around the world, but much of the medium wave and shortwave broadcasters, they just don't exist anymore. Well, the Voice of America in Delano was one of the last of the relay sites, and that's a photograph front view of the facility there. You can see one of the curtain arrays, the dipole curtain arrays in the background. In fact, it was the first dipole curtain array that was erected there. This is the VOA Delano relay transmitting site. And in May of 1944, the ground was broken. Get this, by November of 1944, the same year, they were on the air with their first rhombic antenna 170 feet up. That's pretty amazing. Try doing that today. You know, all the environmental impact reports and all the planning and all the reviews and everything you'd have to go through. This couldn't be done today like that. But just in a short number of months, this station was on the air. Delano was the first of 3 relay sites. The others being, I mentioned earlier, Dixon and Bethany. And they had a receive site that was up the road in the town of Pixley, which is just a few miles up the road. And the idea of the receive site, it was a backup. The Voice of America relay sites depended primarily on the Bell system and their terrestrial links, their microwave links. And interestingly enough, that receive site was never called into service. The AT&T or Bell system maintained that system at 100% availability through that whole time. And the receive site was tested, but they never had to use it to receive material. And let me explain this a little bit more. What is the purpose of a relay site? These 3 sites did not directly broadcast to the consumers in other countries. What they were used for was to relay program material from the studios in Washington, D.C. out to the broadcast facilities, which might be in Hawaii or the Philippines or in Africa or Middle East, wherever they're located. That was the idea of the relay stations. So they're a kind of a way station. And one of the things that led to the demise of the relay stations is satellite. Is they can distribute this material, the program material, via satellite much easier than over HF. Well, the Delano site was shut down at 8:30 p.m. on October 27th, 2007. It was a scheduled program that was on 5890 in Thai. And there was no, and this is the thing that really kind of makes me sad. There was no special observance. 63 years of continuous service by VOA Delano Relay. And there was no special observance. They just pulled the plug and walked away from it. Very sad. Well, I've got some photographs of the construction and some of the early views of the Delano site. This was that I mentioned that first dipole curtain array. This is one of the supports for that first dipole curtain array. There were 3 of these put up. They're 200-foot towers with these curtain arrays. And this is what the site originally looked like. You can see the 3 towers in the background and a number of rhombic supports in the background behind that. There were lots and lots of rhombic antennas, and there still were when we were up there, lots of rhombics left. Okay, so now in looking at the station itself, these early images, the earliest ones show, I mentioned the transcription turntables. So they're receiving via telephone lines, via landline and the terrestrial links, they're receiving program material, cutting a disc on a lathe, and then transferring it over to a transcription turntable to transmit it on these, the Federals and RCA, these are all Federal and RCA transmitters, the 200 kilowatt, 200 kilowatt Federal and the 3 RCA 50 kilowatt transmitters. And this is their control console for audio and the transmitters themselves. Then they upgraded with the advent of tape. They upgraded to the, you can see these Ampex 350s sitting here. And so they would record to magnetic tape and play back on magnetic tape, reel-to-reel tapes. So that was their transition. And again, you see the same transmitter hall here. This is the same console with some different transmitters in here now, possibly some of the same RCAs. But oh yeah, and they did add this the 2 General Electric 100 kilowatts. Now those were gone by the time we got there. The General Electrics, the rooms that they were installed in were vacated. One of the rooms had been replaced by all their satellite equipment, and the other room was their office for their amateur radio club at Delano, which was quite interesting. So in 1964. VOA contracted with Collins Radio to provide 3 821A1 transmitters. And this is the thing we're going to be, again, talking about. These transmitters were very special. These are auto-tuned transmitter. In 1964, these things are auto-tuned. This is a 250 kilowatt carrier. So 1 megawatt of peak power auto tuning in 20 seconds. So it's a remarkable piece of hardware for the
Amazing.
time. And the reason they wanted this, if you think about it at the time, to tune up a shortwave broadcast, let's say a 100 or 200 kilowatt broadcast transmitter, it takes a lot of time to do that. You're looking at half an hour, hours worth of time to retune that transmitter on a new frequency. And why are you tuning it up on a new frequency? Because you're being jammed. So the Russians are out there, the Soviets are out there jamming your relay transmissions. And so you want to move to another frequency, get away from their jamming. Well, when you move, you're on a new frequency in 20 seconds. An hour may take them an hour or more to catch up to you. So you can kind of hop around a little bit and avoid the jamming quite easily with these transmitters. So it was a big deal for these transmitters. So they essentially added this wing to the structure. And this was to house the 3 transmitters. The transmitters would sit on this ground floor. The attic up here is for all the cooling equipment. They're basically big condensers. And I'll explain more about that in a minute, but you got to cool these transmitters. 3 of those transmitters, 250 kilowatts each, are producing a lot of waste heat. So following the shutdown of Delano, now why did they shut it down? Well, one of the big problems, I mentioned technology, the satellite stuff was taking over. The bigger problem was spare parts. They had 3 sites. They had 9 of these transmitters. Well, Bethany and Dixon had been shut down. Delano was still operating, but they were cannibalizing parts from the other 2 sites and bringing them to Delano to keep these transmitters on the air. And that couldn't go on forever. Eventually, they had to shut the thing down. So the Voice of America transfers ownership of the Delano site to the General Services Administration, Government Services, GSA, Government Services Administration. And they're trying to find a new owner for this piece of property. This is an roughly 800 acre parcel up in Central California. It's prime land. They're trying to find somebody to take it over. The city of Delano, they're trying to get the city of Delano to take it. Delano wants a regional airport. So they're thinking, oh yeah, we can build a regional airport here. We can do low-income housing. They even talked about building a prison on the site. There is actually a prison adjacent to the site, kind of catty corner. They were talking about using it as a prison site. Well, they ran into trouble. The California State Department of Fish and Game discovers that there is an endangered species living on this property. And so they're forbidden to do anything to it. They have to maintain it. So all the towers are standing, all the buildings are standing, but all the buildings are going to be gutted. And in fact, some of the transmitters had already been removed and sent off to the Philippines to the site there. I mentioned Dixon had been sold. Bethany is now the Voice of America Museum, Bethany, Ohio. If you go back to if you go to Dayton, I encourage you to make a trip down to the Bethany Museum and see the old Voice of America there. That's kind of a neat thing. But in the meantime, I explain a little bit about where I come into this. I belong to something called the Collins Collectors Association, and we're all about preserving Collins Radio, their history, and the lore of Collins Radio. Collins, of course, was a huge manufacturer of amateur radio equipment. In fact, I'm surrounded by it here in my radio shack. I am a obsessed collector of Collins gear. But it really was some of the best stuff made. I mean, back in the day, and even today, if you talk about avionics, Collins, the avionics systems, I mean, that's the cream of the crop in terms of aircraft communications. So Collins had quite a reputation. Well, before we found out about the site being preserved out there because of this endangered shrew, the Collins Collectors Association got this idea that it might be worth kind of taking one of these transmitters out and putting it into a museum. It turns out that these 821A1s, this was the most powerful broadcast transmitter that Collins ever built at 250 kilowatts. Well, a couple of guys from the CCA, the Collins Collectors Association, Jim Stitzinger and Bill Carnes, who at the time was president, along with the Collins Collectors Association, sought to obtain one of the transmitters from Delano and put it in a museum. And the thought was to put it either into the Collins Museum, which is located in Cedar Rapids, Iowa, or into the Antique Wireless Association Museum that's located in, I can't think of it. It's in New York, in Bloomfield, New York is where it's located. Sorry, had a temporary mind block there. Well, so we first contacted the Voice of America, and they told us, well, that we don't have the stuff anymore. It's gone to the GSA. You'll have to talk to the GSA. So they contacted the GSA, and GSA said, okay, if you're going to move this to a museum such as New York, you're going to have to talk to GSA in New York, because we'll transfer it to them, and then you'll have to obtain it from those guys. Okay. So continuing on, they contacted the GSA, and they agreed that this was a good idea. They thought this was great because they couldn't get rid of the stuff any other way, and it was destined to eventually end up in the landfill, which we certainly didn't want to see. But they levied conditions. The conditions are that the transmitter has to be off the site within 2 weeks of start of the disassembly. And oh, by the way, it has to be on display in the museum within 18 months. Now, mind you, this is a 250 kilowatt transmitter. Now, when I talk about that power level, that's the carrier. And if you're familiar with AM, your peak power is actually 4 times the carrier if you're at 100% modulation. A megawatt, and of course, you've got to talk about efficiency. So we're talking a multi-megawatt piece of hardware that weighs 50,000 pounds. And we're going to move that in 2 weeks and have it set up in 18 months. Well, more on that in a minute. But so in May of 2014, we parachuted into Delano, and our team consisted of Bill. I mentioned Bill before, Bill Carnes, Jim Stitzinger, and one of his assistants from his business. He's one of his helpers, Vince Baker. We were required to have somebody on site from the Voice of America. And Vince was incredible. He knew nothing about the technology. He was not an engineer. He was not a technical person. He was like in finance with the Voice of America. He lived in Fresno, and he would drive from Fresno down to Delano, which is a 100-mile round trip easily or more every day, to come and basically babysit us. Make sure we didn't do anything we weren't supposed to do. Oh, he was there to open the doors and open the gates and all of that so we could get in. Rod Bloxam, who was a former Collins engineer and worked on some of the auto-tune equipment. He was one of the engineers that worked on the follow-on to this series of transmitters, which is the HF80 system, which is an auto-tune high-power transmitter, nowhere near 1/4 megawatt, more like 15 kilowatts, but Rod was very familiar with this equipment. Scott Kerr, who became the president of the CCA and is now the past president. Brian Gurek is a member of the CCA. Dave Jennings, another member who is also a big AM aficionado here on the ham bands in Southern California. A lot of y'all, I know Bob knows Dave really well. We talk all the time on nets on 75 meters a couple of times a week. So that's fun. Dave's got a beautiful Collins transmitter, AM broadcast transmitter that he uses on AM here on the ham bands. Joe Knight from the Southern California Antique Radio Society, he came out and lent a hand. And of course, yours truly, I was part of that team too. So we begin the relocation. We're going to move this thing from Delano to Bloomfield, New York. Okay. Well, you may have visited the Delano site. Anyone who goes up to the, in particular to the Visalia DX convention, drives right by the site there on Highway 99. And in the old days, you could go and get a tour. And a lot of times from the DX convention, they'd make tours out to the site. And you might have stood in this room. This is the main lobby coming into the front of the building. And on the right-hand side are basically office space. On the left-hand side are all the transmitters. Now you see those are two Continentals. Those are 50 kilowatt Continental transmitters, single sideband transmitters. The Collins transmitters are actually behind that wall. And you can see Rod sitting over there waving. That's Rod Bloxham. That doorway, the transmitter's on the other side of this window here. And we had to extract this transmitter out through that doorway. Well, these doorways were too small, so we had to cut the doorway out to be able to get the thing out and haul it out to our staging area, which was out in the back here. Anyway, there's 3 transmitters. The 3 transmitters are back behind this wall right here. Now, what does this thing look like? Here's a front view of the transmitter, and it's a row of racks, and this is essentially just the controls for this transmitter. You have power, basically circuit breakers. You have some maintenance panels here, and there's a driver stage over here. But what's the business end is actually located on the back side of this this row of racks. I mentioned this transmitter, 50,000 pounds. The transmitter itself covers 400 square feet by specification from Collins. It's actually in a little bit larger area than that. The power supply itself covered 250 square feet. Well, I think it's significantly bigger than that at the Delano site, and you'll see a picture of that in a minute. The cooling required 100 square feet of equipment on the second floor of the building. So it's a fairly large installation. As you walk around the back of this rack, you'll notice there's a gate here, and a gate and a cage. This is actually the transmitter itself here is within this cage. What you see here in the foreground, this is the output network going out to the antenna farm. This is feeding out to a switch yard to feed the various antennas. And this is actually believe it or not, it's an antenna coupler and a balun. And the balun is a work of art, and I'll talk about that a little bit later. But this is the output section of the matching network of the transmitter. And if you look up in the air, you see what look like, I don't know, maybe steam pipes or something. This is actually coax, and it's a balanced feed. This is actually 2 pieces of coax that are about 8 inches in diameter that run out here to this thing that looks like a piece of air conditioning duct. And that's actually a balanced feed line that exits the building and goes out to the switch yard and out to the antenna farm. So the transmitter itself is single-ended, and we have to convert that single-ended output to this balanced feed. And I'm going to talk about that a little bit later on. It's an ingenious piece of hardware that I'd never seen before, but quite remarkable. So as you continue in through that gate, that box straight in front is actually the power amplifier. That is the PA, and it houses 2 tubes, and these are 4 CV 100,000A. 100,000A. It's a what is called a vapor phase cooled transmitting tetra. What these things do is they sit in a water bath. It's in a big pot, big aluminum pot, filled with distilled water. The water boils off as steam, goes upstairs to the condensers, and is returned as liquid water. And that's the cooling process. So these things are actually sitting in water. 17,000 volts on the plates. Yikes. So that is the actual PA cage. This is the PA right here. Now, what you see here, and I'll have some more pictures of that in a minute, is that what you can imagine what the matching network, how do you match it? You think about your vacuum tube transmitter. If you're into boat anchors, you've got a couple of transmitting tubes that are in parallel, maybe a couple of 6146s. You've got a pi output network, you've got an input capacitor, an inductor, and an output capacitor feeding 50 ohms, because you're trying to get from some high impedance on the output of that transmitting tube down to 50 ohms to match your antenna. Well, it's the same problem here. The difference is that the output impedance of the PA itself is not in the thousands of ohms. It's in the hundreds and less than 1,000 ohms. So the pi network is rather unique, and I'll show you some pictures of that in a few minutes. But I want to show you the modulator. This is the modulator deck, and this is a push-pull modulator. There's 2 of those 4CV 100,000 sitting in here in a couple of pots. These are a push-pull modulator section, and there's a couple of drivers up here that are also running push-pull to drive these big old tetrodes. So, and you can see these pipes going up. These are the steam pipes. There's actually a Pyrex section here. You can actually see a piece of the glass Pyrex, which is insulating it. And the steam goes up through these pipes, runs up into that attic, and is condensed back to water, and it's returned on some plumbing that comes back in the back here somewhere. It comes back into these pots to refill the pots. So what does a 4CV 100,000 look like? That's one of the transmitting tubes right there. That thing weighs about 90 pounds. Now, one of the things we ran into was how do you extract? We had to get them out. We had to remove it. We had to, reduce the weight. Well, we had all the documentation, and the documentation talks about this trolley system. Well, we didn't see any of this stuff lying around. You figure, okay, they're got to be sitting around here with their maintenance equipment. We couldn't find any of these things. And you can see this trolley, this thing here, and this little winch. This is where Vince came in. We're talking to Vince about this stuff. He goes, "Oh, yeah, I've seen," you're showing a picture of it. He said, "Yeah, I've seen those around here. I think I know where those are." And he disappears and comes back about 45 minutes later, and he's got a cart full of these winches. He says, "Yeah, they were out in the garage." Well, the garage was this big warehouse, is what they call the garage, but they were all sitting out there on the floor in the garage, and he brought them in. And boy, we were happy at that point because we were able to get the tubes out. But it would have been a disaster had we not had those things. But yeah, you unbolt the tube from the socket it's sitting in, which is, you can see where it's been sitting in the water. It's all discolored here. You winch the thing out, and you got a little cart that you roll under it, and you winch it back down onto the cart and roll it away and put a new one in. So speaking of carts, here we are wheeling out the modulator deck on a pallet jack, getting it out of the transmitter room. And here's a little bit another view. This is a view of things like filament transformers, screen supply for this for the PA. Now the tubes are out of here. We've already removed the pot, and what you'll see in a second is what this thing looks like from the other side. And there it is. This is what you saw on the previous picture, is right here. This is where the PA tubes are. This is actually the output going out to the matching network and the antennas. Now you look at this, and it looks like a piece of coax, right? There's a center conductor maybe, but oh, there's a choke. Well, that doesn't make sense. And there's this box. Okay, the box, this box right here, we've removed all the covers from it, but this box is the center conductor of the coax. This box here, this outer thing, is the shield. This right here is the high voltage line feeding the PA. So this is handling 17,000 volts, I think something like 15 amps that's flowing down through here. And that's the RF, the plate blocking choke right there to keep the RF out of the high voltage power supply. So they're actually blowing air through this thing to cool it. And once this is removed, once this piece of coax, this center conductor is removed, you see this where it was. Those are variable capacitors. Those are actually water-cooled vacuum variable capacitors. And those are used to tune the output. And it's in a thing called a multi-pi section matching network. Warren Breeny, who was the chief engineer on this transmitter project, patented this in 1964 when this transmitter was built. And it's kind of like a pi network, but what it is it's a piece of coax. Think of a stretch of coax with a bunch of variable capacitors connecting the center conductor to the shield of that coax along the length of the coax. And that's how you tune it. It becomes a distributed, what they call a multi-pi section matching network. And these things are all, as you look at this cage, and you can really see this in the next picture, that was right over here was where that last photograph was taken. This goes up and over the top and comes down into that, what I said was the output network. It's right here. And a ballon, which is located over here. Now this ballon is truly amazing. It's, again, I say I want to build one of these just to play with it because it's just so cool. You can see the racks have been removed. The PA cabinet's been removed. The first section of the distributed pi line has been removed. So we're making progress in getting stuff out of here. Okay, so that box that I said is the output network. It's actually a filter. It's a harmonic filter. You think about 250,000 watts of carrier. That thing's going to have all kinds of spurious emissions, and you really have to, the spurious emissions probably exceed our legal limit, of transmitting power at 1500 watts, but they have to be knocked down. So they've got a filter in there, a harmonic filter to knock the harmonics out. But this little guy right here is the balun. And I'm looking, I was looking at this and trying to figure out what they were doing. And it suddenly dawned on me what it was. You got two pieces of coax. This is one, this is the other. And the center conductor of this coax is connected to the outer conductor, the shield of this coax. And the center conductor of this coax is connected to the outer shield of this coax here. So it's essentially flipping at 180 degrees. You notice that this is sitting on these vacuum variables. This is actually, this piece of coax is insulated from ground. This one is grounded here. This shield is grounded, but this one is not. This is actually insulated. But that's how they're getting the phase shift. So what comes out, what goes out the top of this cabinet is a balanced line. And it's probably, I'm guessing 600 ohms, maybe. I don't know. I really don't know what the output impedance of the transmitter was out to the antenna array, but typically 600 ohms. So really unique, really kind of an interesting artifact that we found. And this is Rod. We started disassembling, to go to the museum, we wanted to take some of that. And I mentioned that stuff that looks like air conditioning duct. That's where the balanced conductors went out to the switch yard and the antenna farm. And you can see the insulators that held these things up right here. And these went out overhead, and it was in this duct to shield the occupants of the building from excessive RF exposure. It probably helped a little bit, but I don't know how much it would have helped. But interesting seeing that. But Rod's got that big grin on his face. He was having a great time, being the retired Collins engineer and working on this gear. Getting to go out there and see this site was a real thrill for him. And I really enjoyed working with Rod out there. So these are the vacuum variables. These are servo controlled, and that's the auto tuning, right? This is all the control function for this thing. And there's a bunch of these things located all along that multi-pi section matching network. And these are the guys that do that. Now, you notice these couplings, these fittings, these things are water cooled. When Collins first built this transmitter and installed it, they were not. These are Jennings. If you're familiar with vacuum variable capacitors, Jennings vacuum variables. And what they found is these capacitors would get extremely hot and they'd fail. They had a real high failure rate. So Collins went back to Jennings and said, we need to do something different. And they came up with this design of a water-cooled vacuum variable. Who ever heard of a water-cooled capacitor? That was a new one on me, but a water-cooled capacitor. Water and high voltage, I don't know. Those two things don't really mix very well. But anyway, I do have to share one thing. As we dug around in the facility, we found the logbooks for the transmitters, and we noticed this burn mark on one of those, that pi section thing, matching network. And you can see this was actually not a vacuum variable, but this was a fixed vacuum capacitor that was mounted right there with those 6 bolts. And you see this slagged metal. Well, we're looking through the logbooks, and they were trying to tune the transmitter up on 20, somewhere around 20 megahertz. And we could just imagine, they're trying to tune this thing up, and there's this big kapow, and this thing's arcing over 17,000 volts or whatever inside here. And the engineer had noted in the comments section in the logbook, don't ever do that again. So we can only surmise that those two things may have occurred together. We don't know, but it's a great story. But I'll tell you, that just shows you how much power is there to melt that aluminum like that. It was really incredible. The other thing that you see everywhere is this. Very true. 17,000 volts. Yeah, that's definitely gonna do the job. So yeah, they've got the chicken sticks. In fact, you can't power up chicken. If you're familiar with that term, a chicken stick, it's basically a grounded hook on a cable that you hang on the high voltage line. And the idea is that if somebody turns on the power, it shorts it out. And you're also discharging the filter capacitors in the power supply, making sure there's no high voltage before you start digging around inside this thing. Well, all of the chicken sticks had micro switches on the hanger. So you had to put the chicken stick back when you were done to switch the micro switch before you could power the thing up again. So it was a nice interlock that they had on this thing. And speaking of power supplies, you ever seen a power supply you can walk inside of? It's a big room. And what you see here is this is the high voltage plate supply over on the left-hand side. On the far side is the modulator supply. You've got a modulator plate transformer. This is the high voltage transformer for the modulator. This is the actual modulation transformer, and this is a modulation reactor. It's basically a big choke. There are rectifiers located over here and some filter capacitors located back there. And what you see, I mentioned, this is the high voltage for the PA, for the power amplifier. There's the filter caps for the power amplifier right there. And as we look around the room, oh, let me share some statistics on this power supply. That plate transformer, this guy right here, weighs 5,000 pounds. Contains 148 gallons of transformer oil to cool it. It's a 4160. So the mains voltage, 4,160 volts, 3-phase on the primary, 15 to 17,000 volts on the secondary, basically out of the power supply. This modulation transformer over here, this guy in the middle weighs 4,000 pounds. The reactor, this guy, 10,000 pounds is what that reactor weighs. That's a lot of copper. 10,000 pounds, 5.68 henries at 15,000 volts at 22 amps. That gives you an idea. That's power. It's just, oh man. So looking at this a little bit different angle, there's that plate transformer again. This is actually a 3-phase rectifier, and the rectifiers, the diodes, are immersed in oil to cool them. That's how this thing is cooled. And this guy over here, this is a little utility transformer. You know, you got to get 110 volts and 220 somewhere, single phase, to run all your test equipment and all that. So that's what this guy's for. That's a little little transformer to give you your utility supply. Man. Okay, going outside, these are the, you saw I mentioned that feed lines go into those ducts, and here's where the ducts exit the building right here. It comes out on a parallel feed right here, coming out, and goes off to more feed lines that go out to the switch yard. And what you see here, this right here and the other one right back there in the background, those are actually coaxes from those Continentals. I mentioned the 50 kilowatt Continental sideband transmitters. Those come out on coax and they go up to a balun. So there's a balun sitting here that this thing connects to do the parallel feeds out to the switch yard. And speaking of switch yards, that's a switch yard. That's the first switch yard. You can see the feed lines going out here. These are all the transmission lines going out to the switch yard. And the switch yard is a big crossbar switch where they can select what antennas things get routed to. And you can see part of that first dipole curtain array right here. There's another dipole curtain array with these two towers right here. And then these feed lines go off to feed a bunch of rhombics that are off to the side on the right-hand side, which you can't see. And there's a bunch of rhombics out there. Here's a nice image of that one curtain, the dipole curtain. And basically a dipole curtain, and I've got some close-ups, you can see what a dipole curtain is. It's basically got a grid that's grounded. It's a shield on one side. And on the face of that shield are a bunch of dipoles that can be configured in different means, interconnected to operate at different frequencies, and to actually steer the antenna through a phase shift network, which is kind of interesting. You can actually steer the beam of these antennas. So as you look at this curtain array, looking up at it, this is one of the feed lines going up, and you can see here's one of the dipoles right here. And it's kind of like a cage dipole. This tends to make them a little bit more broadband by having these 3 different legs like that on each side. There's one here, there's one here, there's one there, and there's another one up there. There's 4 of these things going up. These are all fed from those that switch yard and all those feed lines coming out there. So that's one of the arrays. Now this is one of the other arrays. This is actually the what they call the medium and high frequency dipole curtain arrays. Those towers are 400 feet tall, and the little ones are 200 feet tall. They're big, and standing at the base of one of those towers, that's what you're looking up into. That's all the feed lines and phasing sections, and they're essentially a delay line. And there's the switch yard for this antenna. Whew. And there's a close-up of one of the switches. It's a pneumatic switch, air operated switch to connect between the different elements in this thing. Now, if you own a guide tower, you know about what they call equalizer plates, and it's typically a thing you can hold in your hand that equalizes the load on the guy wires for your tower. Well, on these 400-foot towers, there's an equalizer plate, and that's Rod standing next to it for scale. It's like, wow. And you can see all the feed lines in the background. These are all delay lines. They're phasing lines to change the phase between the different elements to be able to steer the antenna and change the frequency range. But that is one massive anchor for those towers. So we finished our tour of the antenna farm, which was really a remarkable thing to see. And we go back, and of course, it's gone. We got it out. We're back at the DL8, and it's all gone. All just some scraps left behind. But now the next job, we got to palletize it, shrink wrap it, and load it on the 18-wheelers. And there's Jim Stitzinger with his forklift. Why does Jim have a forklift? Oh yeah, he's a book dealer. He buys and sells libraries. And so he deals with thousands and thousands of pounds of books regularly, and his own trucks to haul that stuff around. So, this is a piece of cake for him to lift up a rack of equipment and stick it into one of these trucks. So we had a couple of 18-wheelers to haul this stuff off to New York. And there it is, all loaded up, strapped down, and ready to roll out. So here's our team. Well, what was left of our team? Here's Vince. We would not have been successful without Vince. He was just so amazing and so helpful to us to do this project. Especially, we wouldn't have been able to get those tubes out without him. Rod, I mentioned Rod Bloxham, K0DAS, myself, when I had a bigger beard and long hair, which is now gone. Dave Jennings. Dave's holding a vacuum contactor. This is one of the high voltage contactors that turns on the high voltage or actually the mains, the primary voltage, that 4160 I talked about. That's a switch that switches the voltage on and off. There's Jim Stitzinger holding a roll of drawings, engineering drawings, and we have all of the engineering drawings from this transmitter and the antenna farm. It's all documented. We've got all that stuff. And this is Tim, who works for Jim in his business with the library books. So that was part of our team. The photo was taken by Bill. So he's not in the Bill Carnes. He's not in the picture, but he's behind the camera. But he was still there with us. Now, that 18-month deadline. Well, needless to say, we made it. And I got to tell you, if you ever get a chance to go to the Antique Wireless Association's museum in Bloomfield, New York, yeah, do yourself a favor and go there. This is the display. This is the transmitter reassembled. Now it's not operating, but it's on display, and we've preserved it with the help of the AWA. And I can't get over what a beautiful job they did of reassembling this thing. And you can see the DL8 front panel here. You can see the modulator chassis back here and the control console out front here. So what a beautiful job they did. And so we're really, really grateful for the fact that we were able to recover this transmitter, save it from the landfill, preserve that little piece of history of the VOA, and have it for everybody to see. So with that, there's kind of a nice overall shot again of the Voice of America Delano relay. And you can see some of that technology that replaced the relay. There's that big satellite dish right there that's probably still out there. Anyway, comments, questions, answers? That's my show.
Thank you so much, Dennis. This was amazing. The scale, I don't think most of us were prepared for the scale of the radio.
Well, we weren't either, to tell you. You see pictures, you read about it, and it's like, oh my gosh. I have a couple of artifacts here that if we've got time, hopefully we've got time. I did take a bunch of charts out. This isn't as long as this talk normally goes.
Sure. Why don't you go ahead and do that? There's a question from chat. Someone wanted
Okay.
to know if there was ever a day when all of those parts were 100% working.
Oh, probably. You know, I'm sure there was at one time before it shut down. But yeah, I mean, that thing ran for 63 years, the VOA site, and that transmitter ran from 1965 when it was commissioned up until they shut down in 2007. So pretty amazing, and quite an interesting piece of technology. I'm still in awe of what we did. It's interesting stuff, but I got to share a couple of things. One is, if you ever wondered what a control panel looks like for a 250,000 watt transmitter, there it is. And the thing that I like about this thing is there's the plate voltage there. What is it? 20 kV, the range, and plate current there, 30 amps. 30 amps so like I said, it's 22 amps at 17,000 volts. This guy over here, there's their watt meter, and it's a directional watt meter, so it'll show you the forward and reverse power. One of the guys that took a tour of VOA was seeing this thing, and it was what it was measuring, and he's going, "You're only running 15 kilowatts? That's not very much output." And the engineer says, That's not the output power, that's the reflected power. 15 kilowatts reflected power. Anyway, this is kind of cool. This is all the controls for the auto tube. So one of the projects I'm working on for AWA, if I can ever find the time to do it, we're going to automate this thing, and I'm building up an automated automation system for it, so it'll behave in a manner like it originally operated. So you turn on the filaments, and the little light comes on. It's over here somewhere. There's a let's see, where is it? There's a filament start. Yeah, so you push the filament start button, and this thing would come on red. And once the filaments are up to temperature, it would turn green, which means you can do the next thing, which is activate the servos, and it'll be red for a while until it's ready to go. And then you can turn on the plate voltage and tune. So you hit the little button here. It says tune start right there. And that 20 seconds later, you're running at full output power, 250 kilowatts a carrier. And of course, this has got frequency selection and what have you on here. So it's kind of a neat little artifact that I was given by the guys, along with a few other panels and some other parts from the transmitter.
It's outstanding. Another question is, how fast can they change antenna directions and or frequency?
That I don't really have an answer to that. I don't really know. You know, the transmitter's back up in 20 seconds. I expect that the antennas take a little bit of time to switch them around. But you know, there was a time when it was all done manually with levers, and it was all replaced with pneumatics. You know, I mentioned the pneumatic switches, which would have greatly sped up the process. What I want to show you, if you're curious about transmitting tubes, there's a little transmitting tube right there. Now, this isn't out of the Collins, but it's similar. It's similar in design to the tubes that came out of the Collins transmitter. This came out of, there were 4 other transmitters on site that were made by a company called Brown Boveri out of Switzerland. They're also 250 kilowatt transmitters, but instead of being a high level plate modulated transmitter, they're pulse width modulated. So it uses a single output tube. This is a 200,000 watt dissipation tube, and it's made by see who made this thing. I can't remember who it's made by. I should know this, but you can see the fins down here. This actually sat similarly in a tub of water. The water boils, goes off as steam, and is returned to the tub to cool the tube. And you can see all the connections for filament and your grids and your plate. So that thing weighs well over 100 pounds, and it's definitely the largest tube in my collection of stuff. But those transmitters, the 4 Brown Boveri transmitters, were moved to the Philippines, and that's where they're operating now, at the Voice of America site there. Why they didn't take this with them, I don't know. These tubes can be, as they say, the tubes can be renewed. These things can be rebuilt if they're damaged. They can be rebuilt and used over. There's a whole ring of bolts on here. This thing just unscrews and you get into it and rebuild it and evacuate it and put it back into service. Unlike I don't have it here anymore. I had a 4CX1000 that I had sitting next to it for a size comparison. Amplifier over here uses a 4CX1000. It's about that big. That's a little bit of difference in size.
Doug would like to know is if frequency changes were scheduled in advance, or were they only performed by necessity when jamming became a problem?
I suspect there were a little bit of both. Obviously, propagation is going to change their schedule, jamming especially, and we never could get a straight answer on this. I conjecture. I mentioned those Continentals, the 50 kilowatt Continentals. I suspect that those are what we refer to as an order wire. So that was the comms between the operators, the engineers at Delano, and the engineers out at, let's say, in Hawaii or in the Philippines, and so they could talk over single sideband and schedule their changes and go through that. The guys out there might be reporting back that they're getting jammed and they need to switch to a different frequency. So I suspect that that's why they were located where they were and what they were there for. I don't know why you would use a sideband transmitter for anything other than voice communications for like an order wire. So, but yeah, I suspect that they were regularly scheduled based on propagation, time of day, frequency, what have you, and then when the jamming occurred, they could switch to another frequency. So yeah.
Very good. All right. Any questions from the floor?
Yeah. Can I ask one?
Go ahead.
Hi, John.
Dennis, I was wondering if you'd remember me.
Of course.
I greatly admired working with this man in April Mel's hospital communications group up in Orange County. He was fantastic. We used to have parties at his house and he'd show us those marvelous old radios. And I said, I've got to say hello to Dennis Kidder. He's one of my favorite people.
Oh,
and
yeah,
Corky
John.
says hello also. So thank you
so
for
and
noticing.
Who's sitting over here in the wings?
Lisa.
Yeah.
Oh.
Hi, Bob. Yeah, this is KF6QNG.
Hi there. And
this is
W6 in the other room. But so good to see you.
It's great to see you, my friend.
Thank
It's been
you.
a long time. Yeah.
Such a great pleasure.
Oh, yeah. Likewise. Oh, man.
Thank you, Michelle.
You bet. All right. Any other questions from the floor?
Hey, Dennis, did you bring the power supply and everything else back with you too?
Parts of it. Oh, can I get to that? I've actually got one of the rectifier stacks, if you can imagine. I got one of the I should have pulled that out. This rectifier stack, and there's like probably about 12 or more of these things in the power supply. They're about this long and about this big around, and it's just all these diodes in a big matrix inside this big cylinder. It's a high voltage rectifier. But yeah, we moved a lot of the stuff. Now, we didn't move everything. We moved, they wanted some of the transformers for display, so we did move some of the stuff back there. You saw one of the I have a picture of one of the transformers getting loaded into one of the 18 wheelers, which was pretty amazing. But yeah, there were other bits. One of the things that was interesting about the transmitter is, if you're familiar, I know you are, Bob, but the term crowbar in a power supply. A crowbar circuit is a thing that will dump the high voltage in a high voltage power supply or a low voltage power supply if you have some kind of a fault, like an over voltage fault. And in the case of these antennas, those are gigantic lightning arresters. And so if they took a lightning hit, you didn't want to keep the transmitter running, you'd want to shut it down. And so they had a crowbar circuit that if there was any arc detected, except that one that I showed you the picture of, obviously it didn't detect that, but if arcs are detected, it will dump the transmitter down within a matter of several milliseconds and just remove the high voltage and shut the whole thing down. To me, that was a pretty remarkable thing. And we took that whole system, which was a wall full of electronics. That was almost like a breadboard up on the wall in the power supply. We took all that stuff down, and that went back to AWA as well. So,
Dennis, what vintage is that system?
which one are you referring to?
Oh, the one you're describing with the lightning.
Oh, that was this transmitter. There's the 821A1. It
So
was
1960s? Is
yeah, 60s. Mhm.
Wow.
Yeah, it was mid 60s is when it was commissioned, 1965, and like I say, ran to 2007. So at Delano, the other ones were shut down before then. But yeah. Whew.
So was it actually a true crowbar circuit that shorted the output of the power supply?
It shorted the output of the power supply.
Oh, that must have been something to see.
It was really
just not from very close.
Yeah. Well, the power supply, that room, the interlocks on that room were so elaborate. There's no way you could be inside that room and have the power on. It's just impossible. You had there were multiple key locks that you'd have to unlock something, take the key out, put it into something else to lock it. So in other words, the two could not be actuated at the same time. You had to deactivate one to activate the other one using the keys. And so that was all tied into the door.
Very interesting.
The doorway. But the other thing was, if you needed to see what was going on inside the power supply while it was operating, there's a little window, a little doorway, and it's a sheet of, this thing is in cinder block. The whole room was all made out of cinder block. And I'm sure there was some additional shielding in there, because you think about high voltage like this, we're talking X-rays, right? So you open this little door up, which was probably a lead plate. And this glass is about 6 inches thick, and it's lead impregnated glass. And you could look through that glass and look inside the power supply while it was operating. But you didn't want to do it for very long, because you were going to get bombarded with X-rays. So it was pretty crazy. But
you said the transformers were oil filled. Do you happen to know what kind of oil?
That I don't know. I was asked that question also before, if it was PCB type oil, like what was it? The
transformers.
Well, yeah, they're like GE, the GE Pyranol is what I was thinking of.
You do not want that.
Yeah, you don't want to be around that if it's burning or vaporized. Just sitting in static in a container, it's okay, but you don't want to ingest it. You don't want to breathe the vapors from it. That's for darn sure. But
Wow. You mentioned the spare parts were the problem. That was the reason that it was retired.
Well, part of it, yeah. I mean, it's funny. One of the rooms there, which was kind of like a garage in the main transmitting building, was kind of like a garage, a loading dock and a roll-up door and all that. It was littered with wooden crates full of parts. And it looks like they just brought stuff in, and the parts were from Dixon, is where they came from. They had stenciled on the boxes things about Dixon, so they transport stuff down from Dixon to keep this transmitter running. And we found a lot of interesting stuff in that room, including spare transformers and things like that, which was kind of amusing. Yeah, I guess you'd have to have a spare. If you burned one up, it would take you probably a year to get a replacement.
Yeah, that's true. There has been a recent large transmitter failure in the AM shortwave world, and the photographs of the cracked transmitter made the rounds on Twitter, and it was quite remarkable. The scale, pretty large, and it took it's going to take about a year for it to be repaired. There's only one company that's going to be able to do it, and they're getting around to it. So yeah, it's really remarkable. All right, any other questions from the floor? Thank you so much, Dennis. This is fantastic.
My pleasure. And I saw a comment from somebody who said that they were a member of AWA and has been to the museum. Outstanding. That's cool. I love it.
Very cool.
Yeah.
All right, any closing comments before we turn it back over to Joseph to close the meeting?
Well,
very interesting, Dennis. Really enjoyed it.
Thank you, Bob. Me too. It was a fun project, bittersweet. You think it's the end of an era, and it was bittersweet to be part of that, but a once in a lifetime opportunity, really, to be part of that too. So
Was the documentation digitized? Is it part of the museum?
I'm not sure what they're going to do with it. We obtained when we went through the building there, we did get several sets of documentation, which are all the engineering drawings, and I actually have a set of manuals here for it that I was given. So it's like it's a bookshelf full of manuals for this transmitter, the operating instructions. But I would hope that they would digitize it. That would be something to do. One of the things I mentioned, Jim Stitzinger, his role in all of this, he is an archivist for Collins Collectors Association. So he maintains quite an extensive library of Collins documentation. In fact, Collins actually comes to him for documentation on certain products that they no longer have the documentation on. So he's maintaining a set of the documents for this thing. But when the Voice of America was going through kind of a spring cleaning a couple of years ago, and they asked Jim if he wanted some of their documentation because they were just going to send it to recycling. And it's all types of historical data on the Voice of America, just photographs and stories and documents. And so he said, yeah, I'd be happy to take it. He figured, yeah, I'd be a couple of boxes of stuff. Truck showed up with palletfuls of documentations. And I know he was just thrilled to get that stuff, knowing Jim. He's really into that kind of thing. So he shared some of that, and I hopefully he will digitize some of that stuff and get it out on the CCA and share it with the VOA's museum back there in Bethany. So
wow, outstanding.
Yeah, it's been, what a project.
All right. Well, I'm going to turn the meeting back over to Joe, our president. Joe, take it from here.
Thanks again,
fantastic. Thank you so much for those presentations. Very interesting, very informative. It's always good to hear about fun stuff that has been going on for ages. Not getting switched here for some reason. There we go. Hi. All right. So yes, thank you all for attending. I know we lost a few people, so thanks to those of you who stuck around for the ending here. Get a lot of good questions and answers there. Next month, we will be back in person for a hybrid meeting. So if you feel safer at home, if you just can't make it, if you're out of country or out of town, feel free to dial in via Zoom. Same Zoom meeting link every month. It doesn't start until someone with the admin account, usually me, starts the meeting. So that's why you weren't able to get in right at the beginning if you joined before I started it. So it is the same every month. So thank you all for coming, and we will look forward to seeing you next month.
Yeah, next month we will be doing a workshop on FL Digi, and what we'll be doing is taking recordings of shortwave radiogram and seeing if we can decode them. What we're going to do is have them on USB thumb drives. We will not try to get them over the air, and we'll also have a number of interesting things from Mark Raptis. He's going to bring in some cool stuff. So it's going to be a hands-on walk around the room, and we'll also have a short video presentation about how to decode shortwave radiogram. So that's what's planned for April.
So bring your HTs, and if you've got multiple little antennas for your HTs, bring them.
Yeah, and I meant to talk earlier. When they were talking about decoding the audio coupling method, we actually did that at one of the Oceanside CERT events to decode a message from a picture message from the ISS. So we were out in the parking lot with our handhelds and our phones listening to the ISS transmit a picture message, and it came across. It worked great. So yeah, the audio coupling method of making sure your mobile device can hear the static coming from the radio does work for that. So fantastic. All right. If anybody wants to hang around and chit chat, you're welcome to. I'm going to go ahead and stop the streaming.